We already worked with the DOM. We created elements, inserted them, we queried for elements. You learned how to work with elements. Now in this module, we'll take it one step further. We'll have a more detailed look at what we can do with DOM elements. We'll work with their coordinates, their sizes. We'll learn how to attach data to them. And we'll have a look at what else the browser offers us when it comes to working with what the user sees and experiences in the browser window. In detail in this module, we will have a look at how we can attach data to DOM elements and why we might want to do that. We will work with element coordinates and sizes so that you learn how you can use JavaScript to find out where an element sits and which size it has and how you can also modify these values. We'll also have a look at a concept called templates, and I will also show you how you can add scripts dynamically, so how you can load scripts and create scripts with JavaScript, which is pretty meta, I guess. And as I mentioned, we'll have a look at what else the browser offers to us, and there we'll have a look at the navigator object, the location object, and window.history, and you will learn what these things are, what we can do with them, and why they exist. For most things in this module, we'll use this little application we worked on in the last course module, which was optional. So if you skipped that last module, you find the finished snapshot attached and you can use that. I would recommend that you go through the code and get acquainted to it. One thing which I want to highlight, which you learned about earlier, but which we haven't used in a real project before, is that in this project, I actually pass functions around as callback functions. For example, here, to make sure that in this project, where we got two boxes with projects, we can move projects between these two boxes, and for that we pass functions around into our two project list objects, which are two instances based on the same class, to trigger different actions in different instances of these classes. So just have a thorough look through this code, and if you want to learn how we wrote this and why we wrote it like this, check out this last course section. With that, let's dive right in and let's have a closer look at what we can do in the DOM and with all these cool DOM elements. I want to start with attaching data to DOM elements and why we might want to do that. Now, in this project we worked on, we do display a tooltip. We got this tooltip component here, and right now what this does is when I click on more info, it adds a tooltip at the very bottom of the page, which of course is something we'll change, with some dummy text in there. And when we click on it, it is deleted. Now, the dummy text is displayed because I'm setting this here, and the problem I have is that I don't know which text should be displayed for which project. Now, we could be managing data like this in our JavaScript code in an array of projects. But here we actually got some HTML code, which, for example, could be pre-created on a server and sent to us on a client like this. And therefore, we don't really have that tooltip data available in JavaScript. Now, it's also not available in normal HTML tags because it shouldn't be rendered to the screen by default. Instead, what you can do is something I already prepared here for you. We got this special attribute on these list items which represent these different projects. Data-extra info. Now, this is not a special attribute you have to attach extra tooltip info. Instead, the data-attribute in general is a special attribute you can add to your own elements to attach any kind of data to them. So you could add data-id, data-whatever, data-whatever attribute or value you want to append or you want to store on one of your DOM nodes. And the idea behind appending data or attaching data to DOM nodes simply is that you don't have to manage it in JavaScript. In cases like this one, where we don't manage the projects in JavaScript, we have a loose connection to the rendered DOM nodes. We store the IDs of projects in JavaScript, but that is it. We don't store any other project data there. And yes, we could do that, but sometimes you have scenarios where you want to store data in the DOM and attach it to DOM elements so that when you work with that DOM element, you can read data from it. Now for that, this extra data dash attribute was created, which you can safely use to attach any data you want. And you can add as many data attributes here as you wish. Now the only question is, how can we read from that attribute? And for that, you got a special property you can read from. So here in app.js, when I create a tooltip, here I got access to that tooltip element which I created. Now I also want access to that DOM node for which I'm creating a tooltip, because on that DOM node we'll find this extra attribute. Now here in the create method where we create a tooltip, we don't have access to this DOM node, but I am creating my tooltip on the other hand in my project item here, which in the end is my JavaScript representation or connection, I should say, to that DOM node. It's not the DOM node itself, it's just an object which knows about the ID of that DOM node, and therefore we can select that DOM node. And we can do this here in show more info handler, which is triggered when I click the more info button. And there, before we created a tooltip, I can reach out to the DOM node itself, so to the project element, for example, with document get element by ID. And then this ID is a property of this project item, which is the ID of that project here in my DOM. So I can query it by that. This gives me access to this list item, and on this list item we got this special data attribute. Now to read from this, we can reach out to project element, and there you got a special data set property. And that's important to keep in mind. These data dash attributes are all merged together in a data set property. Now let's console log that to get a feeling for what's inside there. Now, before we can try this out, one important note about this ID. This refers to this property, or at least it should, but due to the fact that show more info handler is attached to an event listener, we should actually bind this here. Otherwise, this will not refer to the same thing inside of show more info handler. And with that, if we save that and we then reload and click on more info, you see this is what's getting printed. A DOM string map, which in the end is a JavaScript object where every attribute you added, every data attribute you added is part of that. And you see the naming is automatically converted to use camel case. So I added extra dash info. This becomes an extra info property in this DOM string map object, which I access on the dataset property of the selected node. And that's just something you have to know, you have to keep in mind, or I guess you can always console log it if you want to see what's in there. This gives us access to this text which was added on the node. Now, if you would want to add your own content through JavaScript, that's of course also possible. For that, you can reach out to the project element and then simply access dataset and dynamically add a new property there. For example, some info. Set this to test here, and what you'll see is that if you save that and you reload and click on more info, if you now inspect this DOM node here, you see besides data extra info, we now have data some info added down there. So this then automatically gets added for you automatically when you add a new property to dataset on your DOM node. So this is how you can set data. Here, however, I want to read data, and I got my tooltip text here simply by accessing project element, dataset, and then extra info was the name. And then we can forward tooltip text to the tooltip as a second argument to the constructor, for example. And then in the tooltip, we just have to accept this. So here we could add that text, get that text, then add it as a property, this text equal text. And then here in create, where we set that text instead of using dummy, we can now use this.text. And with that, if we save that and we reload and click on more info and scroll to the bottom of the page, we see this custom text, which is part of the DOM node. The tooltip still is in the wrong position, but we at least extract the right text. And this is all possible with the special data attribute and in JavaScript with data set, which helps us access this data attribute value. Now, of course, though, the tooltip still is in the wrong position. Here at the bottom of the page, that's not where we want it. It would be nice to display it here, below this button, for example. So below this DOM node to which it belongs. And for that, we need to find out where exactly that sits on our page, which coordinates this has. And we'll need to find some information about its size as well, as you will see. And for that, we first of all need to understand how items are positioned. Well, that happens with the help of CSS and simply based on how the browser renders a page. But we also need to understand how we can get the exact coordinates, the exact calculated width, and so on. Because as you know with CSS, even without being a CSS expert, you probably know you cannot just assign pixel values. You can also use something like rem, which is dynamically calculated. You can use percentages. You can use media queries to use dynamic different sizes. And therefore, if you want to find out the exact size as it was rendered, you need JavaScript, and you can indeed get coordinates and so on of any DOM element you want. And that's exactly what we need here. For that, attached you find a zip file with two files in there, and that would be the sizes HTML file and the sizes CSS file. If you extract these files, drag the sizes HTML file next to your index.html file and the sizes CSS file into the styles folder. And with that, you can go to your page here and temporarily replace index.html here at the end with sizes HTML, and you'll find this page here. If you load that, you will get an error regarding a missing sizes.js file. You can simply add one, should be empty anyways. And this is simply a basic dummy file here, dummy setup, where we can practice with sizes, positions, and so on. Now for that, to get access to this box here, we can select it by the ID, or here in the DevTools, you can also select it. And then when you select it here on the right, if you mark this div here, you can also use it in your console with $0. This is just a shortcut the browser developer tools offer to you, and then you have direct access to the DOM node and you can work with it. Now, which sizes and which properties do we have available that help us with understanding the positioning, the width, and so on? Well, for example, there is a method you can call getBoundingClientRect. If you execute this as a method, you get back an object which gives you some useful information about this box. And you can run this for any element on the page. Now what this gives you is a couple of coordinates and sizes. To understand these values, you need to understand that the browser basically renders the page in a two-dimensional coordinate system with an x-axis from left to right and a y-axis from top to bottom. And that's important. It's not like a traditional coordinate system where the y-axis would go from bottom to top and from left to right at the bottom, but instead it's all starting in the top left corner. And that makes sense if we consider how a web page is rendered. It's rendered from top to bottom, not built up from bottom to top. This coordinate system also thinks in pixels, and therefore in the top left corner, we would have the coordinate 0, 0. X has a value of 0 and Y has a value of 0. All the way on the right here, we would have Y still equal to 0, but X would be, well, basically the width of your screen or the width of this document. All the way on the bottom left here, X would be 0, Y would be just as high as your document, and in the bottom right corner, X would be as big as your width and Y would be as big as the height of this document. So this is how you can read this. Therefore, if you see X, Y here, this basically means that this box which we selected has its top left corner at a position of 100 pixels down and 100 pixels from the left. So the X coordinate on the screen is 100 and the Y coordinate is 100 from the top left corner. And we have that positioning because if you check out the sizes CSS file, indeed, I have a margin of 100 pixels set for the body, which means any element in the body, and this div with this ID is in the body, is moved in 100 pixels from top and left because that's reserved as a margin for the body. So that's how we get there. We also got the top and the left value, and that's the same as X and Y here, as you can see. And most of the time that will be the case. If you have a negative width or height, that can differ depending on the exact positioning and your CSS code. But left and top simply gives you the coordinates of the leftmost and the topmost point of this box in the coordinate system, and typically that's the same as X and Y. More interesting is bottom and right. Well, that in the end is just the combination of left and top, or X and Y, with width and height. So bottom and right basically tells you where the bottommost and the rightmost point is in that coordinate system that starts on the top left. And therefore width and height are also important, of course. Should be pretty self-explanatory. Width gives you the total width of the box, height gives you the height of the box. So this is some rough general information you can get about this box. Now you can also dive into more specialized properties though, if you only need a single value there, or if you want to have different values for some of the sizes based on whether you want to include a border or not and so on. So let's have a look at that as well. So we saw get bounding client rect, which gives us some general data. Now you can also get more specialized data by diving into your DOM element with special properties. For example, there is offset top. Offset top gives you the distance of the topmost point here to, well, the top of this coordinate or to the start of this coordinate system. And of course, you don't just have offset top, you also have offset left. Makes sense, I guess. So these are basically your x and y values here, or your left and top values from that object we saw before. You also, however, have client top and client left. And now that's a different thing, as you can tell. Where offset gives you the outer positioning, so the position of the box in the coordinate system, the client properties give you the inner positioning. And specifically, client top and client left tell you how far it is from your left and topmost point to your left and topmost point of the content of this box. And the content of the box is basically the entire box without any borders and potential scroll bars that might be rendered in there. So at the moment there is no scroll bar here, but I have a border of 15 pixels, and therefore that's exactly that value which we see here for client top and client left. You can also get some of the sizes for that. You can get the offset width, and you can get the offset height. And that's the entire width and height of this box, including all borders and scroll bars. Now, unsurprisingly, you also have client width and client height. And that's, again, the inner width and height without borders and scroll bars. Therefore, for the width, it's basically the width of 300, which we saw just a second ago, minus the border times 2, because we got a border on the left and on the right. And if we had a scroll bar, that would be deducted as well. The same for the height. Also interesting, this content here is scrollable, as you can see. The scroll bar here on Mac is only temporarily rendered and therefore not included in that calculation I just showed you. But regarding the scrolling, we can also get some interesting data. We can, for example, get scroll height. Now, what scroll height gives you is the entire height of the content, including the part which is currently not visible in the box, so which is outside of the box at the bottom here, for example, or now at the top. So scroll height is the entire height, including the non-visible parts because they're currently scrolled out of view. You also have another interesting value, scroll top. Scroll top gives you information by how much you scrolled that content in the box. So if I scroll the content all the way to the bottom, for example, you see now I have a value of 240 there because I basically scrolled the content up 240 pixels, you could say. If I scroll somewhere in the middle, that obviously shrinks. If I go all the way to the top, so I haven't scrolled at all, I got 0 again. Now you don't need to memorize all these properties, of course. On MDN, you can check out the HTML element article, and there you find all the properties there and on the element article to be precise. And there you can read more about that, and then of course also just play around with them to get a feeling for what these values do and what they offer. Attached, you also find this simple slide where I just summarized the key values for you and what they mean and which values they give you. One note about the entire document width. If you want to get that, you got two options. You can use window.innerWidth and window.innerHeight. And that should give you the width and height you have here inside of your window. So without the DevTools, without the URL bar at the top and so on. But the problem with that is that if you had a visible scroll bar on Internet Explorer, for example, or on Windows in general, you might have that. Then this will actually include the scroll bar and not subtract it from the width and height, and therefore actually give you more width and height than you, well, actually have available for your content. Hence, a better way of getting the real available width and height is to go to document element, which is your root element, including head and body, so to say, and there you use the client width and the client height. Here, this gives me the exact same values as window inner width and inner height, simply because I have no scroll bar here. But again, for the reason I just mentioned, if you had one, these values are more reliable because they will deduct any visible scroll bars and give you the real width and height that is available. Now, before we continue working with width and height, one short extra lecture regarding MDN and the element docs we find there and the HTML element docs we find there. Now that we understand how inheritance and prototypes works, this picture here actually also makes more sense, or should make more sense. JavaScript, or this DOM API exbrowsed by the browser in JavaScript, I should say, simply also works with multiple constructor functions, with multiple classes, if you want to call it like this. And this is how they are related. The way you should read this is that every HTML element is inheriting basically from element, so has an element prototype. Any element prototype has a node prototype, and that in turn has an event target prototype. And that makes sense because if you remember earlier, I explained that elements are just specific type of nodes. So it makes sense that they have a node prototype, but then they bring their own properties and methods as well. And you even have more specific types than just HTML element, because you have specific types of HTML elements. If you scroll down a bit further on this HTML element article, you find the more specialized versions. And there are a bunch of them, as you can see. For example, there is the HTML input element. The specific thing here is that it has all the properties, or it has access to all the properties and methods of HTML element, of node, and of event target, but it also adds its own special properties and methods to which only an input element has access. Here, for example, the labels property, a property other HTML elements don't have access to, but HTML input elements have access to it. Now, how do you create such a HTML input element? Well, you don't have to create these objects or these instances. Instead, when you select a HTML input element from the DOM, you will automatically get such an object of that type with all these properties and all these methods. And thanks to how prototypes and the prototype chain works, we then also have access to everything from HTML element, from node, and from event target. So this hopefully now also makes a bit more sense now that we had a look at object-oriented programming and at prototypes in earlier modules. Let's now go back to our main project here by again changing to index.html. Now there we want to position this tooltip here. If I click on more info, I don't want to render it here at the bottom. Instead, it would be nice to kind of position it near this element. To do that, we need to tap into JavaScript, into the app.js file, and there work on the positioning with some of the properties and tools we now learned about. It's in the place where we create the tooltip, so therefore inside of the tooltip class, in the create method, where we can configure it and where we can position it. To position that tooltip, we also need to know where the host element, so the element that is responsible for showing that tooltip, lives in. So in the end, where this project item where we clicked on more info, where this can be found. And for that, on the tooltip, when we create it here in the constructor, I expect one extra argument. I also want to get the host element ID here, so that I can actually pass this to super host element ID, because in the add component, which is our base class, we expect that host element ID, and then we use it to select that host element and store it in a this host element property, which we of course therefore can then also access from our subclass, because we can access any property which we have in a base class, or therefore in a prototype, also from a subclass or an object using that prototype. And hence here in tooltip, we now pass this on to our base class component, and therefore we'll have access to this host element property. So what can we do with that? Well, here in create, where we create our tooltip element, before we add the event listener maybe, let's console log this host element and then get bounding client rect, this method we saw earlier before, just to see whether that all works and whether we can get that information about that host element positioning and so on. So now to test this, we just need to make sure that we actually do get a host element ID here on the constructor of tooltip, because at the moment we're expecting this, but we're not sending this when we create a tooltip. So here in project item, where I create a new tooltip as a third argument to the tooltip constructor, we should now forward the ID of this project, which we can get under this ID. That's the property of this project, which holds the ID of that project. And with that, if we go back and reload, let's click on more info, and indeed we get our object here, and there we get the coordinates of this project DOM node and its size and width. The tooltip now also is created here based on the logic we have in that component class, where we now use the host element, now that we got it, to insert our tooltip there. And whilst this doesn't look too bad, it's not exactly how I want to position this. Also because I don't want this to grow and shrink when I add a tooltip. But we'll come back to that. For now, let's focus on the coordinates. And there we see to the left, we have 63 pixels in the end here. To the left. To the top, it's 161. And the exact values here are, of course, not values I set up like this in the app CSS file. Instead, that depends on how the browser renders this, from top to bottom, on system-specific settings you might have, for example, regarding the font size, because I'm using rem in here to set my sizes. And hence, these are the calculated values, which are, of course, exactly the values I'm interested in, because I want to have the current position I have on the screen to position this tooltip. So now back in the script, we can position this tooltip in the tooltip create method here with some information from that bounding client rect, or to also practice with some of the other properties I showed you with some information from those properties. So for example, I am interested in the host element position left, and I'll name the constant like this, therefore. And we get this by accessing this host element and then offset left. Remember, that's the distance from the start of our coordinate system on the page to the leftmost point of our element. Now I also want to get the host element position top, and this can be fetched with this host element offset top. So now I know the x and y coordinates of my element. So the top left corner of the host element, so to say, which coordinate this top left corner has. Now I also need the height, because I want to position the tooltip at the end, at the bottom of this element, and not in the top left corner. So I can get my host L height here with this host element, and now the height is the client height. That's the height of the content. I could also get offset height to get the full height, including any borders. But here I have no borders, so that should be the same. With that information, we can try positioning our tooltip. For that, let's calculate an X and a Y position for the tooltip. X could be the host L position left, and then maybe plus 20 pixels. And if you work with values here, these are now always pixels, because what you fetch here are also pixels. And let's get a Y coordinate. And here I want to use my host element position top. So the position of my top border in the coordinate system, so to say. And to that, I want to add the height. Now, important, when I add something to that, since my coordinate system starts in the top left corner, we push elements further down. So if I have the coordinate of my mouse cursor here, and then I add 100 to that, and we render an element at that new position, it will be rendered 100 pixels down from that point, because the coordinate system goes from top left to bottom right, basically. That's how the browser lays out the web page, and that's how you have to think about it. So we have to add the height here to go down on the page. Now I'll actually then deduct 10 pixels to not go down the entire height, but only height minus 10, basically. And now let's try out these coordinates for rendering the tooltip. Now to position an element, you don't do this by accessing tooltip element and then offset top and setting this equal to a value. All these top and left coordinates are just read-only values. If you want to assign a new value, you do that with CSS instead. So here we can access the style property of the tooltip element, And then we can set left equal to X. And now important, really important, and a common mistake. If you're assigning a style, and we need to do that here as I explained, it's not enough to just set this equal to some number, which is in the end what we have here in X and Y, but you need to set it up as you would write it in CSS code, which means if you work with pixels here, you have to add px after the value. So here in app.js, I need to add plus px. So we in the end set this to a string, which is now made up of my number and pixels, and therefore this gives me something like 500 px. Just an example. And we do the same for tooltip element style top and set this to y plus px. If we now do that and we save this, let's reload and click on more info, and you'll see no difference. And the reason for that is that we can set left and top. But due to the way CSS works, and you can't magically change this with JavaScript, which is good, you also, first of all, need to set one other style on the tooltip element. You need to set the position style to absolute, and then you can really position the element in the absolute coordinate system on the screen. Otherwise, it's always positioned relative in the document flow. This is how the browser and CSS works. So now by setting position to absolute, we can make that work. And now if we reload, indeed you see now the box doesn't grow anymore, and we render the tooltip in this position. Now that's great. You'll encounter a strange behavior if you now scroll to the bottom project in the first box and you click on more info here. You see, the tooltip is totally in the wrong position now. Now what could be the reason for that? Well, if we take a closer look and we scroll this element down again, I would say this tooltip is roughly in the same position as the tooltip is here for the first element, just ignoring that we scrolled it. So the scroll distance here, that's the problem. It's not taken into account here when we calculate our top and leftmost position. And indeed that is what's happening. When we get the coordinates of an element, these coordinates ignore whether the element has been scrolled somewhere or not. Now to include the scrolling information, we just have to find out by how far we scrolled the content in this box, and we of course can find out how far we scrolled it. I showed you how that works. So we can get our parent element scrolling, or however you want to name it, by reaching out to this host element, then to the parent element of that to get the entire box, the entire unordered list, and not just a single project item, and then the scroll top property. Remember, this tells you by how far you scrolled in that container. And in the end, this parent element scrolling, that is something we have to deduct from our calculation here. So we have to deduct it from there, so that we move the tooltip up a bit and don't position it at the original position or the original coordinates of that element, but the actual position, which is adjusted by the amount of scrolling we did basically. So now by deducting this, if we reload again and I scroll up this box here, this project, and I click on more info, now this is in the right position. Now it's not sticky if you scroll, that would be a bit more advanced. You would have to set up event listeners, listen to scrolling, and it will dive into event listeners and so on in the events module where we can learn way more about event listeners. But for now, this is not the focus. The important thing here is that we are able to now position this correctly with the help of the coordinates we're getting and with the help of the width and the scrolling we're getting. Speaking of scrolling, we can not just find out by how far the user scrolled on the entire page or inside of a box, but we can also actively scroll the user somewhere. And a good example would be when I add buy groceries to finished projects. It gets added there, but of course it gets added at the bottom, and therefore I can only see a part of it. Now maybe we want to scroll in this box where we add an element to make that element visible. And we can do that. You can actively control scrolling through JavaScript. Now let me show you how it works here in the developer tools. Let's select this section here. And in there, to be precise, let's select the unordered list. If we now expand the styles, you see that there I cap the height and I make sure that we can scroll to see the content which doesn't fit into the unordered list. So that unordered list is scrollable. Now with it selected, let's go to the console and use $0 again to interact with that unordered list. And now there, you got a couple of methods you can call. For example, scroll_to. Scroll_to takes two coordinates, x and y, where you can define how much you want to scroll to the left or right, and how much you want to scroll to the top or bottom. Now here we can't scroll left to right, so there's nothing we can set there. If you set this to 100 on x, for example, it wouldn't have any effect. But we can scroll on the y-axis. Now if I set 0 here, then I tell JavaScript that I don't want to scroll at all. Not that helpful. If I set it to 50, however, then this might be better, because now I tell JavaScript that I want to scroll down to 50 pixels. If I hit enter now, you see indeed this changed, right? It scrolled there. Let me show this again. Let's repeat that same command. Boom, it scrolled. If you set it to a very high value, well, then it just goes as far down as possible. Now you can also not just scroll to absolute values, you can also scroll relatively with scroll by. With scroll by, I tell JavaScript by how many pixels I want to scroll down. So if I enter 50 here, I'll have the same effect as before actually, but you'll see a difference now if I am at 50 and I repeat this command. Now I scroll down 50 pixels more. If we would do the same with scroll_to, scroll to 50 here, you will see I scroll to 50 pixels, and if I repeat that and I am at that position, nothing changes. So you can control whether you want to scroll to a specific position or by some amount of pixels. And combined with the fact that you can get the coordinates of any element on the screen, you could of course then also use this to tell JavaScript to scroll to a specific element by getting the coordinates of that element and then scrolling to it. If you want to make a specific element visible with scrolling though, there is an even easier way. You can also go to that element, for example the project item which we added, here with the help of this add project method in the project list class, and make sure that this element, when we move it, gets scrolled into view. And to make sure that this happens, we can go to this place where I move the element, here, and then on that element, which you want to bring into view, there you can call scroll into view as a method. And this will do just what the name suggests. So if you now save that and reload, you will see that if I add buy groceries to this finished projects box, it gets scrolled into view automatically. And of course, the same if I add something to active projects. So this can be useful too. Make sure that it scrolls into view. Now, of course, what you might notice is that scrolling here always means jumping. It immediately is there. We have no animation. Well, you can, in some browsers at least, Chrome and Firefox support it, you can set up how scrolling should be performed. By passing in an object here to scroll into view, where you can set the behavior to smooth. The default is auto, which just jumps there, but with smooth, you'll get a tiny animation. So if you set this to smooth here, for example, and you reload, and then you add groceries here to finish projects, watch the bottom box, you see it scrolled there with a nice animation. And that might be nicer than just jumping there. Again, it's not supported in all browsers, specifically Internet Explorer and Safari don't support this feature. But you can still add it to your code, and on these browsers, it will just not have any effect. On the browsers that do support it, though, you get this enhanced behavior. You also have this configuration available, by the way, if we select the unordered list again, on scroll_to and scroll_by. There you can pass in the coordinate pair, or alternatively pass in an object where you set top and left, top by how much you want to scroll from the top, and left how much you want to scroll from the left. So I'll ignore left here because I don't want to scroll from the left, but I'll set top to 50. And then here you can also add the behavior and set this to smooth. And now here you'll also get that animation. Same is available for scroll by, as I mentioned. Like this. So this is how you can scroll and how you can control scrolling from inside JavaScript. A feature which of course also can be helpful to make sure users see the content you want them to see. So enough of the positioning and sizing and scrolling. Let's come back to working with content. And there one thing we did a couple of times throughout this course because we had no better way was that when we wanted to set up some HTML code that should be rendered or some content. We always did this here in our scripts. Now in this example here, or in this project here, I actually have no HTML code in my script. But it would be easy to add some to the tooltip, for example. You could say that when we create the tooltip here, we don't just set some text content, but we set some inner HTML here, which for example includes a h2 tag where we say more info, and then below that a paragraph where we output the actual text here with string interpolation like this. And if we do so, and I now reload, and I click on more info, we get this kind of tooltip here. Now, of course, you could adjust the styling, but the core idea is here that now I have this HTML code in the script. And this is not ideal because you might be working in a team where other people are responsible for the markup and so on. Or you're not working in such a team, but you don't want to have all that HTML code in your JavaScript code. Now, obviously, this is a very simple HTML code, right? But if you had longer HTML code, lots of HTML code in there, this could get more and more cumbersome. And thankfully, the web has a solution for this. We can use a special HTML tag in our HTML code to kind of set up such to be used HTML code, which we don't want to render right from the start, but which we want to eventually use from inside our JavaScript code. And for this, we can use a special tag, the template tag here. Just add it in your HTML code, in your body. And the special thing about the template tag is that its content by default is not rendered, but it's part of the DOM. So you can query it and use it, and then use it in your JavaScript code, but it's not getting rendered by default at the beginning. We can add an ID to the template. We can, for example, assign tooltip here, and then move this HTML code from our JavaScript file into this template. Now, this string interpolation will not work here, so for now I'll just have my empty paragraph here. We'll have to insert content there from JavaScript in a second. So now we got the HTML code in the HTML file, which makes sense. Now in JavaScript, we can use such a template, of course. For that here, we can get access to our tooltip template with document get element by ID, and then looking for the ID we assigned to the template. And now we get access to this template element. Now to utilize this template, we can create a new constant here, tooltip body, for example, and there we can use document import node, to which we then pass tooltip template.content. And this in the end gives us the content of our template tag, so the h2 tag and the paragraph we set up there, and essentially creates a new node based on that. That's what this line does. We should set up true here so that we do a deep import, which means we really import everything in the content of the template, which is exactly what we want. And now we got that body available, which we can add to our tooltip element. So here we can call append and append the tooltip body. Only thing we should do before we do that is, of course, we should adjust the paragraph in there and insert our text. And we can do that with tooltip body, query selector for a paragraph, first matching paragraph because we only got one, and then there set text content equal to this.text. Now, of course, this takes up more lines of code than the approach before did, but this simply moved the HTML code out of the script, which is especially useful for longer snippets of HTML code, because now you can manage all your HTML code here in the HTML file, and then just import it into app.js, adjust it, tweak it, and configure it, maybe insert your dynamic data, and then use that. And that's the advantage of this approach. So with that, if we save that and we reload, we get the same result as before, but now simply managed in a more elegant way, which is much better and actually how we should do this, since this helps us split our HTML logic, our HTML code from our JavaScript code, which can help us work in teams and keep our JavaScript code easier to manage. Last but not least, it's also more convenient to write HTML code in an HTML file in an editor like this one than in JavaScript in a string, because we get better auto completion and so on in an HTML file than we do in a JavaScript string. With this project is pretty much finished. But there's another cool thing you can do with JavaScript, which many people wouldn't expect, or which might be strange when you hear it the first time. You can also create and run a script with JavaScript. Let me show you how that would work. In app.js, let's go to init. So to app init, here at the very bottom, this static method. And in there, you can create a script dynamically in JavaScript. How would that look like? Well, let's create a new constant, for example, some script. And we create it with document create element, like we always did, but now we create a script element. Remember, there are script tags in HTML, and therefore, of course, you can create such a script tag as well with create element. So now some script is in the end a script tag which we created. Now we can insert some text content here, and for example, enter alert hi there to throw an alert. This is valid JavaScript code, right? Now we just need to add it to our document, and we can do that by going to document, and there, in the head maybe, append our script, which is stored in the sum script constant. The result is that when init runs, our script here should be added. Let's save that and reload. And indeed, here's my alert. And if I save this or click OK, then we're done and we see the content. Because if we now inspect the rendered DOM in the head, indeed we have that script here. So you can create and add scripts dynamically. Now, for scripts like this might be nice, but I'm not sure if you really need that. Because if you just want to execute some script code, you can just write it like right here, right? It's more interesting if you have some other script file which you only want to download at a certain point of time. So where you want to control when the browser loads this script from inside your JavaScript code. So let's say we had another script here, analytics.js, where we just send some analytics data. So for now, I'll just console log sending analytics here. Very simple script. Now, if we go to our HTML file and we import this here with script source, then we, of course, run this right away. Of course, I can add defer here, but that means once the parsing is done, this script executes. Now, maybe you have some app where you only want to run your script after something happens. So, for example, after the user clicked a button or anything like that. So for that, I'll add a new static method here. Start analytics. And in there, I now want to dynamically load that script. For this, we can, again, add a new script element with document create element script. But now I don't add any text content to it. Instead, you can set analytics script.source. You can set the source property just as you can set the source attribute here. And this will, well, basically tell the browser where to find that script. Then here you should set up a path as you would do it here in your HTML file. So not seen relative from the JavaScript file, but really just as it would be added to the HTML file, because that is where it will be executed in the end. So that would be assets/scripts/analytics.js in this case. And then also maybe add the defer attribute or the defer property and set this to true, so that this is only loaded after all HTML parsing has been done. Now I just need to add this here to my head with document head, for example, and then append my analytics script. And now whenever we call start analytics, this script should be loaded and executed. And now we could do this, of course, in the init method here, but we could also say we want to do that whenever one of our buttons here is clicked. Then we just should make sure that we don't add this same script multiple times. So here, to keep it simple for now, I'll just do it when init runs. So here I'll call this start analytics. And if I now save that and we reload and open the console, you see sending analytics here. Now, of course, this executes right away when the app starts because I called it here in init. Nonetheless, this script was actually added dynamically through JavaScript, and you could have added it at any point of time, not just when this page loads. For example, you can go to the index.html file, and in there, at the very bottom, add a footer where we can add a button where you could say Start Analytics. Now, of course, you typically wouldn't add such a button to your application because most users will probably not start analytics on their own, but it can be useful for us here to prove that this script really only is added and executed when your JavaScript code runs. So I'll give this an ID, Start Analytics button. And with that ID, we can go back to app.js, and then in here, in init, not do this here, don't start the script like that, but instead reach out with getElementById to our button. So that was the Start Analytics btn ID, which I assigned here. And then add an event listener to this button so that upon a click, we execute this Start Analytics. Now, if we save that, you will not see Send Analytics when I reload, but you'll see it once I click this button here at the bottom. Now you see that as soon as I press the button. Now the button is a bit strangely positioned here, simply because I'm zoomed in that far and I have given it an absolute positioning at the bottom. If I would zoom out a bit more, this looks better. But it's not so much about the styling here, the behavior is the important thing. In the developer tools, you can also go to the network tab, and in there, you see all the files that were loaded. If I now reload, you see everything is loaded, but the analytics JavaScript file is not one of the loaded files. If I click on Start Analytics though, you see now it's getting downloaded here. Super fast, of course, because it's a small file, but only once I click the button. So this is pretty neat, and this is how you can add and run scripts dynamically from inside JavaScript. Now, one important note about adding scripts dynamically like this: it's a powerful feature, but of course you want to do it with care. You should especially be careful when it comes to dynamically rendering user-created scripts, because that opens you up to some attacks here. And it is something we'll have a closer look at in the security section later down in the course, where we talk about attacks like cross-site scripting attacks, which in the end try to inject malicious code into your code. So if you dynamically add a script, make sure you don't do it based on some user-entered content, or at least validate that content and sanitize it before you execute it. But again, we'll have a closer look at this topic in the security module. So now with the dynamic script added, I'm pretty much done for the interaction with the DOM, which I wanted to cover in this module. However, there are some other nice features the browser exposes to you in JavaScript that also allow you to influence the user experience. And one of these cool features is a timer, which you can set, or actually two different kinds of timers you can set in your JavaScript code. Let's say instead of starting our analytics here, when the user clicks a button, we want to do this 3 seconds after the page was loaded. And for that, indeed, you can set a timer. You do this with the built-in setTimeout method. Under the hood, this exists on the window object, but as you learned, you can omit window and just call anything on it like this. And setTimeout does just what the name implies. It sets a timer. Now, setTimeout takes 2 arguments. The first argument is a function which should be executed when the timer expired. This can be an anonymous function, both an arrow function or a normal function, or of course you point at a function, like in this case, this Start Analytics, so that this method is executed when the timer expires. The second argument then is, well, the amount of time you want to give the timer. So for example here, 3000 means 3000 milliseconds, so that would be 3 seconds. So this is a number in milliseconds this timer should take until it then executes this method. Now, this also, by the way, is an example for some asynchronous code execution in JavaScript, a topic we haven't really had a look at yet. But as you will notice is when this timer is set, it will not pause your entire script execution. You will be able to click all buttons and have your script work as expected. Instead, this is registered by the browser somewhere in the background. The browser manages the timer and also just registers that this function should be called when the timer expired. And then once the browser sees that the timer expired, it will come back to your script and execute this function for you. So it's important to understand that this will not pause script execution. Instead, the browser will manage all of that for you in such a way that your script can continue to run. It will not pause. Another side note, you can also pass a third argument here, and that would be an array of arguments you might want to pass into that function when it executes. This function here, this method, however, needs no arguments, so we can just run it like this. And hence now if we reload, we should see sending analytics here after 3 seconds. Here we go. Start analytics, of course, doesn't do anything. So that's the first kind of timer I wanted to show you. This is a timer which runs once. Sometimes you also want to have a timer that runs on an interval. So that runs every 3 seconds, every 5 seconds, every 100 milliseconds, whatever you have. And you can do that too. Let's maybe do that in the analytics.js file. In there, instead of logging this right when the script is loaded, let's set a timer because we might want to send analytics data to our server every 2 seconds, let's say. For that, we can use setInterval, an alternative to setTimeout, which does something different though. Here I pass in an anonymous function. Again, can be an arrow function, but doesn't have to be. And in here I'll say sending analytics data, like that. Now the second argument to setInterval then is the time when this should be sent. And it will be sent every X seconds or milliseconds. So if we enter 2000 here, this function here will execute every 2000 milliseconds, so every 2 seconds. You also can pass in a third argument, which would be an array of arguments, which will then be fed into this function when it is executed for you. Here we don't need that, so I'll just set it like this. The result of that is that if I now save that and reload, for 3 seconds nothing happens, but thereafter every 2 seconds, therefore initially after the first 5 seconds, we got this information being sent, which is why this slowly increments here. Every 2 seconds, this is getting sent to the server. Now, if you want to stop a timer or want to stop an interval, you can also do that. Let's say we change our button here at the bottom to stop the analytics so that no more data is getting sent. So we can set this to stop analytics button. This should either stop this timer if it still is running, or if we already are on the interval, it should clear that. So to start with this timer, here after setting the timer, I will add an event listener, document get element by ID, stop analytics btn was the ID I assigned to this button here at the bottom. And there I want to add an event listener, a click listener, where we can use an anonymous function. You could, of course, also set up a method, but I'll just use this. And here I want to stop this timer if it still is running. For that, it's useful to know that this timer will actually return an ID, so to say. So we can store this in a constant timer ID. And here you can then run clear timeout, another function provided by the browser in JavaScript. And to that, you pass the ID of a timer, of a timeout, which you want to stop. So now if I save that and I reload, if we click on stop before the 3 seconds expired, you'll see we'll never see any analytics data being sent. On the other hand, of course, if I reload again and we wait until this is sent for the first time, if I now click on stop, this will not stop the interval. It will also not throw an error because the timer already expired, so that's okay, but the interval, of course, continues because we're not saying anything about the interval here. Though we can also clear the interval if we want to. We can go to the analytics.js file where I set up this interval, and I'll copy that code in there and essentially just store my interval ID here, because just like set timeout, this returns an ID for that interval. And then instead of using clear timeout here, we would use clear interval and pass the interval ID to it. Though, little fun fact, you could also use clear timeout and it would also work, but since we have it, it's better to use clear interval because it's clearer about your intentions and simply more descriptive. So clear interval for clearing intervals, clear timeout for clearing timeouts. And with that in place, if we now save that and we reload and wait until this starts to send data, here we go. If I now click on stop analytics, you'll see this will not increment any further because no other data is sent because we cleared the interval. So these are timers in JavaScript and how you can control them, what the browser does with them. It manages them behind the scenes so that your code execution is not stopped. As you see, I can interact with everything just fine, even though there's a timer going on. And intervals and timers are therefore a crucial feature which help you, well, time things or do things on a regular basis, something which you actually need to do quite often in JavaScript. Besides timers, the browser also has a couple of other nice objects or features it exposes to us in JavaScript. For example, and I'll show you this in the console here, there is the location object. It's on window.location, and therefore, as you learned, you can just access it like this. And if we have a look into it, we see that's an object with a couple of properties and methods, and they're all related to our URL and the page we're on. Location can be used to also navigate the user away. For example, by setting location ref equal to a new URL, something like academind.com, for example, which is my own page. If you now hit enter, you see we switch to that page. You can also navigate with replace. This is a method which you execute to which you pass a URL. The difference to setting ref is simply that you can't go back because it will replace this page in that browser history, which is in the end stored. So the back button won't be able to go back to this page after you use the replace. Another alternative would be the assign method. That's pretty much the same as setting the ref property, and you can use both interchangeably depending on whether you rather navigate by setting a property or by calling a method. And of course, you got a couple of other properties and methods in there as well. For example, you got host, which tells you on which host this page is running. Since we served this locally from the files, we got no host there. But if you are on some other page, like academind.com, for example, then you will see that host actually gives you the domain here. You also got origin, which is the full domain, including the protocol which was used. Also the path name, which is the part after the domain, and here I'm just on /nothing. If I were on a list of all my courses and I would execute this, you would see that now I get this part after the domain being logged here. And this can be useful to find out where you are on the page in JavaScript, for example. A nice feature, especially for more complex JavaScript-driven browser-side applications, where you might want to render different content based on the path that was entered up there, and you might want to control the entire navigation through JavaScript. Something which is actually possible, but beyond the scope of this course, and typically done with the help of JavaScript frameworks, something we'll also have a look at throughout this course. So that's the location object. You also have window.history. Or just history, therefore. Now, location and history kind of work together. Location allows you to edit the browser history by navigating around or by replacing the page. History then allows you to interact with that history. For example, you can call the back method to go back. So I could say location ref and set this equal to academind.com. And then there we could call history back and be taken back to the page where we came from. So this, for example, allows you to move the user back to the page where he came from. A feature you might have seen on some web pages where you are asked if you're old enough to visit the content. Don't know which pages could ask for something like this. And then if you answer, no, I'm too young because, well, does anyone ever answer this? I don't know. But you clicked that no button, then the page might want to move you back where you came from. You could do this with history back. You also have history forward to go, well, to the page you came from if you navigated back there. And you can also inspect the length of the history to find out how many steps the user did in this tab of the browser. So how often you went forward to a new page, essentially. So how often you could go back, therefore. Because you also got history go to go back 5 steps in that history and take the user to the page he was on 5 navigations ago, so to say. So definitely feel free to play around with location history to get a feeling for how you can move your users around. Be aware, of course, that moving users around is not always giving them the best user experience, though, so you want to do this with care. Now, besides location and history, there also is the navigator object, also quite interesting. This allows you to interact with the browser and the operating system of your user, so to say. Of course, only in a limited way, not unlimited access. If we expand this, we can find some information about the browser the user used, for example. And here you might see something strange. This here says something about Mozilla, even though I am using Chrome here. Even more interesting is a specific property, which is often used to check which browser the user is using, the user agent property. If we access this property, navigator.userAgent, you might expect information about the browser the user uses. Though if I use it, we see information about Mozilla there, Apple WebKit, and then, also something about Chrome, but also about Safari. Now, what's up with this? This actually looks the way it does look for historic reasons. Browser vendors in the past used to fake this to make sure that their browsers could have access to all features website might be using in their scripts. Because in the past, browser support was pretty different for different web features. And hence, some programmers working on websites used user agent to find out if the user is using, let's say, Internet Explorer, and therefore they wouldn't run a certain script if that browser was used. Now, as browsers evolved and maybe Internet Explorer 7 included a feature which version 6 didn't include, that script that prevented Internet Explorer from getting access to certain features of the website would still block access even though support might now have been added to the browser. Therefore, browser vendors started to put basically all browser names into this user agent string because this is set by the browser, so the people building the browsers, of course, can influence what shows up in there. And hence, browsers basically faked to be another browser so that they could get full access to whatever the script wanted to do, so that the users of that browser had no limited or restricted user experience. Hence, this is not really that useful. Now, attached you find a link how you can still parse this, a certain way of reading this that should still give you mostly reliable information about which browser your user is using. But if you really need to know which browser your user is using, you should not rely on this string in the end, but instead check if a couple of features are available, because by checking for feature availability, you can narrow down which browsers users are using in a better way. And you should also check out the browser support module in this course, where I also dive into techniques that allow you to write scripts which work in a broad variety of browsers or that fall back to some behavior if a certain feature is not supported. So I just wanted to show this because I find it kind of amusing to understand how this evolved over time. As I said, with the attached link, you can parse it, but do it with care. Now, Navigator also exposes many other features. For example, it also exposes access to the Clipboard API, which allows you to add something to the clipboard or paste something into some input field, for example. It gives you access to geolocation, which allows you to locate your user with getCurrentPosition, which allows you to get the user position. You would do that by then passing in a function which executes once the position was fetched. And in there, you can console log the data, which you will get automatically as an argument. So this function will be called for you by the browser once the location was fetched. And then here, if you enter this, you have to allow that the browser fetches your location. And eventually you'll get that position object with your coords object in there, where you can find out which coordinates the user has. And there's more in Navigator. Now, it's impossible to cover all features in a course, so as always, I strongly recommend also using MDN and just playing around with these features to learn more about what you can do there. We'll also see some of these features being used throughout the course, so that will also be a nice way of learning about what you can do there. And with that, we had a look at location and history, which allow you to move your user around and find out where the user is on and so on. And Navigator, which allows you to interact with the machine, with the browser itself, so to say. For example, to get the position or to get some vague information about which browser the user is using. Now, to come to an end in this module, there's one last built-in or global constructor function, you could say, that helps you deal with dates, and that's the date object and constructor function. You can use date in a broad variety of ways, and attached you find documentation that allows you to dive deeper into date. You can, for example, create a new date object like this, and what this gives you, if I hit enter, is indeed the current date and timestamp here. So that's the current date and time at which I'm recording this specific video here. This is what you get with new date. Now, actually, this is really an object you can work with, though. If we store it in a constant, then on this constant, so on this stored object, we get a couple of methods. For example, we can call getDate to get the day in month, 24th in this case. We got getDay to get the day in this week, and so on. So there are lots of methods that allow you to analyze this date, get the time, for example, since the beginning of time in JavaScript land, which is January 1st, 1970. So since then, this is the time of milliseconds that has passed. And this can sometimes be helpful for calculating differences and so on, and much more. So there are a bunch of methods you can call to work with a date. You can also construct a date with new date by passing an argument to the date constructor. If you don't pass anything, you get the current timestamp, but you can also pass in a date instead, which JavaScript then tries to parse. Now, for one, you can pass in an existing date object. This would simply store that date as a new object in date2, but you can also pass in a string to describe a date. And of course, then JavaScript will do its best to parse this as a date. For example, I could pass in 07/11/19, and now what JavaScript derived is July 11th, 2019 from this date. Now again, the attached resources allow you to dig deeper and find out which formats you can use there, how you can also specify minutes and hours and so on, and much more. Now, these date objects can be really useful because, for example, if you would want to calculate the difference between this first date, which is today, and date 2, which is in July, then we can just execute date minus date 2, and this gives us the difference in milliseconds. And therefore, if we take that difference and, for example, divide it by 1000 to have the difference in seconds, divided by 60 to have the difference in minutes, divided by 60 again to have the difference in hours, and then by 24, we get the difference in days since that date. So that's just one example of what you can do there. So definitely check out that date object, also with help of the attached documentation. If you need to work with dates in your application, if you need to store a date, run some date calculation, or anything like that, this object has got you covered. Now, besides the date object, there is also one other built-in object which I want to show you because it can be important. And that's the error object built into JavaScript. You have to use new with it, because that's a constructor function actually, to create a new, error. To this error object, to this error constructor function, I should say, you can pass a string, which will be your error message. Something went wrong. And when you created such an error object, you can throw it with the throw keyword. Now, you might recall that we saw this earlier in the course when we had a first look at error handling and at try catch. There, I actually didn't throw this or such an error object. I threw a normal object, which you can also do. You can throw anything as an error. You can throw an object, you can throw a string like an error, and that will, cause an error with, that information. But you might want to consider throwing an error object using this dedicated error constructor function. When you do so, you don't just get your message, which is automatically put into a message property of the created object. You also get a stack trace, which basically tells you where this error was thrown. In this case, in the console, which is why we see anonymous here. But if we would do this in a file, we would get the file name and the file numbers and so on. So besides just passing some error message, this can give you more information. Also, since it's an object, you can add stuff to it. You can create your error object with new error here and put in your message, like something went wrong, by passing it to the constructor. But then, of course, you can go to this object and you can add other properties as well. You see, by default, you got this message property and the stack property, because this error constructor function creates an object which has these properties. And that's of course nice to have. You also got a name here, and you can change that of course if you want to, but you can add anything else like an error code if you wish to. That's all possible, and you can always console dir, not log because that will always just give you the error message, but console dir that custom error to get a full view at the object which was created under the hood, with my code property here, with the message property and the stack property. So that's the error constructor function. It creates an object. What you pass to the constructor function is automatically stored in the message. When you console log your error object, it will automatically give you that message. So console log will directly access the message property. But if you console dir it, you get full access, and you can always, of course, access all these properties with the dot notation, as you can do it on any other object. Because it is like any other object, basically. The only special thing about it is that you can throw it particularly well because it gives you extra error information, like the message or this stack trace. So the error object can be really important for custom error handling. So that's it for this module. We had a look at element positions and sizes and what you can do there. We had a look at scrolling, how you can scroll the user and how you can find out how far a user scrolled inside of an element or on the entire page. You also learned about some other nice browser features like dynamic script addition and template tags. You learned about timers which you can set and intervals. And now at the end, we had a look at location and history and navigator, some other nice objects that allow you to interact with the browser and hopefully provide a good user experience in whichever JavaScript-driven application you're building.